Hey, hello there. Today's Leetcoding challenge question is called Sum Root to Leaf Numbers. We have a binary tree containing digits from 0 to 9, so each node inside this binary tree will have a value to be a single digit from 0 to 9. And each root to leaf pass inside this binary tree represents a number, and the question is asking us to sum all the root to leaf numbers. Looking at the example, we have 40, 495 and 491, so we basically add those three numbers together and return the sum. That's the question. So how we go about solve this? We're just gonna traverse the tree in the DFS search fashion. So we try to complete a root to leaf pass before we explore other paths. Once we reach the leaf node, we can add the number that's represented by the pass towards some kind of accumulator, and once we done all the DFS search, the accumulator will be the sum we want. So yeah, that's pretty much it. Just gonna do a DFS search, and after that it will be done. So it's gonna be linear time and linear space. Yeah. Pretty simple question, really. Because we do DFS search, we want to use a stack so that we can pop from the back, and the element on the stack is going to be a tuple, which is going to be the node we're currently looking at during the DFS search, and also the partial pass sum. So initially it's 0. So we're just going to do DFS search until we run out of stuff to look at. So each iteration we're going to pop the node and the partial sum out. And then we're gonna check if this current node is a leaf node. Oh, before that we update this partial. And then we check for if the node is a leaf node. The node will be a leaf node if the node does not contain any children. If we reach the leaf node, that means the partial will be the number that are represented by this pass. So in the beginning, it will be, after we pop the root out, the partial will be updated from 0 to 4, and when we move to 9, it will be updated to. Okay, sorry. I think the calculation is wrong. I have to multiply 10 to the partial so that I shift the wrong position. Yeah, so in the root here, the partial is 10 multiply 0 plus 4, so it's 4. When we move to 9, it will be 40 multiply the prior partial by 10 and add the node's value, so it will become 49. And when we reach the leaf, it will be 490 plus 5. So the partial sum here will be the number that's represented by the pass if we do this kind of update all the way. So if it's a leaf node, then we put this onto the total, and otherwise we would just extend the stack to explore its children's. Since that we might be pushing a null pointer onto the stack, we're just going to do a really quick check here. If the node is null pointer, we just ignore it. Yeah, so that's the iterative approach, DFS search, to solve this problem. Let me see if it's working. Alright, so yeah, that's pretty much it. In the worst case, when the tree is a degraded singular linked list, the time and space here are both order of n. So if it's a balanced tree, the space will be just the space will be log of n. But the time is still order of n. So in the worst case, it's both linear in terms of time and space. Yeah, that's it. Pretty simple question for Friday.